We are solving problem related to parallel and series grouping of resistance, and we have seen some problem. Now again we see some different types of problem and their technique to solve. Here we have to find RAV, that is we have to find the resistance between these 2 point, equivalent resistance. Again in this problem we have to find the equivalent resistance between 2 point. So let's first solve the first. Here we see that these are in series. So this first we have to find the equivalent, and that equivalent will be parallel with this. Again we find the equivalent, and that equivalent will be series with this. Similarly in this side, this is series, and that will be parallel to this, and that now that equivalent will be series with this, and finally we get 3 resistance in parallel. So let's solve one by. Here in this case also we can solve using serial and parallel combination, techniques of series and parallel. First solve first problem. Here it is given, this is in series as shown, this is in series. So finally this will transform into like this, R plus R, here 2R, and these two will be in parallel with this. So here we see that this is parallel with this single resistance. Again we see here this is in series, so its equivalent will be parallel to this. So here we have equivalent, and this is parallel to this. Now these two are in parallel, again these two are in parallel, and these two equivalent of these two parallels grouping will be in series with this. Here we see that, and calculating its value, which comes out with 2 by 3R. So here this is in parallel with this, and again this is parallel with this. Now these are in parallel in series, so we can calculate easily R plus 2 by 3R, and similarly R per 2, and this and this will be equivalent of this 2, and equivalent of this 2 resistor will be parallel with this resistor, which is shown here. Now the equivalent of this is 5 by 3R, and equivalent of this is 5R by 3, because these are in series. Now these three all are in parallel, so we can use the formula for parallel combination, which is equal to 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. Here we have to find the equivalent resistance between A and B. So we have written RAB, that is this represent equivalent resistance between point A and B. So it is equal to 1 by 5R by 3 plus 1 by R plus 1 by 5R by 3. Solving we get finally RAB equal to 5R by 11, that is 3 by 5R plus 3 by 5R plus 1 by R. Now this will add up to 6 by 5R plus 1 by R, now 5R, and this will be 6, and this will be 5. So RAB will be 11 by 5R. So reversing, RAB will be 5R by 11 answer. In the second case, here it is shown here. Now here we see that these two are in because this point and between this point is equal to B. So these two are in parallel. Again these two are in parallel. So we get the value of this equivalent, and this equivalent and this equivalent will be in series as shown in these figures. Now the equivalent value of this is R by 2, and equivalent value of this is R by 2, and now these are in parallel. So we have again we calculate this value using parallel combination. So the value of this parallel will be like R, because R by 2 into R by 2 by divided by R by 2 plus R by 2, and solving we get the value R. Now these three are in parallel grouping, so RAV will be, we can use the formula, and so 1 by RAV equal to 1 by 2R. plus r 1 by 2r, or 2 into 1 by 2r plus 1 by r, solving 1 by r plus 2 by r, so RAB will be r by 2 answer. Next we have this combination. So here we see that here these two are in parallel because there is no resistance between it. Then this point, and if we consider this point, then it will be in parallel. Again this will be in parallel. Again this two will be replaced by one single equivalent resistance. Again this two will be replaced by one single resistance. Now it is shown here R, these are, and these two equivalent is R, and again this equivalent is R. So we are left with this combination. Again we see that these four are in series and these four are in series. These these four are in series and these three are in series. Okay, so first calculate this value, then this will be 4r and this will be 3r. So we have written 4r and 3r. Now these all are at now these two are will be in parallel because this point one end is connected here and other end is connected here, so this will be in parallel. So getting this value, equivalent value, will be series with this. So here it is shown, it is in series with this, and calculating the value, finally we have this value have 4 by 3r and this is 3r. Now these are in series, so we can calculate directly, and this equivalent of these two will be parallel with this. Here it is shown. So we had value of this value is 4r by 3 plus 3r, which is equal to 13r by 3, and so RAB will be r into 13r by 3 divided by 13r by 3 plus r, and solving this will be 13r square by 3 into 3 by 13r plus 3r, or 13r square by 16r and 13 by 16r answer. So we have solved seeing the different circuit and what is the nature of circuit. First we have to decide the resistance are in parallel or series, and their combination we have to see their combination, and solving one by one we get final result. Now the concept is next concept is our concept of short circuiting. Here we will know about what is short circuiting. So first let's see the definition. When a conductor of negligible resistance is connected across a resistance or resistor, it is called a short circuit, and in this case the total current passes through the conductor having almost zero resistance, and across resistor means parallel to the resistor. For example, here it is in point A and B there is a resistor, and we are connecting a wire of negligible resistance or conductor of negligible resistance, that is its resistance is very small compared to this. So this will be called short circuiting of this resistance. Now because there is no resistance, so current will pass through this and there will be no use of this resistor because current is not flowing. So it is assumed that current is not flowing through this because all current will pass through short circuit. Okay. As a result, the resistance becomes ineffective and so neglected. Mathematically, we have Vm minus Vv equal to I into R. Now, because its resistance is negligible, equivalent to 0 we are considering. So, I into 0 equal to 0. So, hence we have potential at A equal to potential at V. We are considering hence Va equal to V. Thus, the potential of 2 points remains same So both the points will be at same place. We can replace this both point at same place. Now based on this concept, let's solve some problem. Here we have to find the equivalent resistance between A and B. This represents equivalent resistance RAB, that is in point between A and B. So first see what happened. Here we see that this is conducted by a conductor of negligible, because resistance is not shown here, so it is a conductor of negligible resistance. So we can consider that point P and point A, because there is no resistance. So this will be at same point. Again here see, this is connected with a negligible resistance conductor. So this point B and P will be at same point. So considering it, for example, A and Q will be at same point, A and Q, and this resistor and this resistor has one end at same point Q and A. So say point Q and A, and this resistors and this resistor has a same point, one end at same point at P. Here it is shown, B and P. So the circuit will transform into like this. And finally we calculate, for example, you want to solve, first write A and Q at one point and B and P at one point, because both points are at same potential. So we have written. Now let's see, this resistance is one is connected with, so first connect it with A or Q, will be same, and another end is at P, so here it is connected. Now see, this is connected to Q1 end and another to P, then another is Q and another is P. This is P, because both B and P is same. Again we have seen these two resistance. Now third resistance we see, it is one end is connected to B, so one end is connected to B, and other end is connected to Q, so other end is connected to Q. So from this arrangement we see that these three are in parallel, so we can calculate RAB equal to R by 3. In the next problem, find RAB. Again we have to find the equivalent resistance between point A and B. The circuit diagram is shown here, and here it is short circuited. So this resistor will be of no use, that is all current is passing through this like this. So this can be removed because it is not dropping any potential. So this figure will be like this. Now these two are in series, and so we have to calculate in series. If you see, this will be like this, the figure is this, and now we have this is again we see that so this will transform into this figure. and this equivalent will be 2 ohm and 6 ohm by 2 ohm. Now these two are in parallel, so equivalent resistance will be 3 ohm and 2 ohm, 3 ohm and 2 ohm. So finally we get RAV equal to 2 plus 3 plus 2 equal to 7 ohm. Here it is clear that this is short circuit, so this will be removed. Again here with this see that this all are in short circuit because we have a conductor at this point. So this potential and this potential will be same, but this potential and this potential will be not same. So these two will be in series, parallel, and which parallel value will come out 6 ohm. So 6 ohm and 6 ohm we are showing here. We have this circuit is short circuited, so we are left with 6 ohm. Now these are parallel, so we solving the value comes out to be 3 ohm, and now these three are in series, so final value is 7 ohm. Now concept of Wheatstone bridge. Concept of Wheatstone bridge. If we have circuit like this, then we say that this is a Wheatstone bridge, that is R1, R2, R3, R4, and there is a R5, and this is the point A and this is point B. Then this type of arrangement is called Wheatstone bridge. And if the Wheatstone bridge is said to be balanced, if R1 by R2, R3 is equal to R2 by R4, then this is in the balance condition. Or R1 by R2 equals to R3 by R4, then it is also in balance condition. It means that there is no current will flow through this middle part, and this will be removed directly. The Wheatstone is said to be balanced if R1 by R3 equal to R2 by R4, or R1 by R2 equals to R3 by R4. And in this case, no current passes through resistance R5, that is point Q and B are at same potential. So we can remove R5 from the circuit to solve the problem. Now based on this concept, let's see one problem. Here it is shown we have to find the RAV, that is equivalent resistance between point A and B. So we see that this is the case of Wheatstone bridge. Here this is R1, R2, R3, R4. Now see it is balanced or not. So R1 by R2, we have 10 by 25, R1 by R2 10 by 25 equal to 255, and R3 by R4 is equal to 2 by 5. So hence we see that R1 by R2 is equal to R3 by R4. So ratio is equal, so it is a balanced Wheatstone bridge. So this resistor will be of no use, and this point will be at same potential. Here it is keep in mind that this point and this point will be at same potential, but these are not connected to each other. It is to keep in mind that we have to remove this resistor. We have not to join these 2 points. Okay. If we write that is, for example, in this case, if we write here give a point name and give another point name, then both will be at same potential, but they are not connected to each other. We have to keep in mind this point. So we have removed this directly. So our wheat stone is balanced. So finally we get this has been removed now 10 ohm plus 25 ohm, and this side is 2 ohm plus 5 ohm. So these are in series, these are in series. So finally we get this circuit will be like this 35 ohm and 7 ohm. Now these are in parallel, so we get RAV 35 into 7 by 35 plus 7 equal to 35 by 6 ohm. Next, find RAV in the given figure. Here it is, and we have to find this point. This point is this is point A and this is point B. We can replace it if we turn it in this direction and this into this direction. This will transform like this. Circuit will be like this. So here we see that you only see this part. Then this is a valence Wheatstone bridge, because R by R equal to 1 and R by R equal to 1. This is ratio is equal R1 by R2, R1 and R3 by R4. So we have to remove this. So we remove this and we have removed this. Now this will be R equal to equivalent like this. Now this is in from only seeing this is in series, this is in series. So finally this will transform into this like this. This will be the equivalent of these two is 2R and equivalent of these two 2R. Again this is in parallel, so we have to calculate the parallel value of that resistance. Now the next we transform R, and the equivalent of those parallel is R and R. So hence RAV will be 3R. Next question. Here it is shown we have to find the RAV, that is this point and this point we have to find. Then we see only this part of the circuit. Then this will this is a Wheatstone bridge, because this and this seeing this and this. So this is a Wheatstone bridge, and here again if we take ratio, that is R1 by R2 and R3 by R4, we get same value. So it is a balanced Wheatstone bridge, so we have to remove this. Now removing this we have sorry, this was the problem and we have to get this. Oh, sorry. Here we see these two are in parallel, okay, and this is the again this is in parallel and this is in parallel. So solving this all circuit, that is equivalent of this and equivalent of this, then our circuit will transform like this. And because this is in parallel, so it will be equivalent of this 2 is R by 2. Here it is shown. Again equivalent of this 2 is R by 2, it is shown, and equivalent of this 2 is R by 2. Now if you see this part, then this is a Wheatstone bridge and it is balanced, so this can be removed directly. So we are left with circuit like this, because this will be R by 2 and this will be R by 2. This is R and R. Now this is in series, so add up again, this is in series and this 3 will be in parallel. So r by 2 plus r by 2 r, and the equivalent of this is 2r, and this is r by 2. So rab will be again 1 by rab 1 by r plus 1 by 2r plus 1 by r by 2, solving 2r equal to 2 plus 1 plus 2 equal to 5 by 2r, hence rab equal to 2r by 5, answer. Our next concept is